Three, two, one.
Hi, good day doctor. I'm Cik Nur Fatah binti Cik Muhammad Junus. SA21007 is my ID number. For the infrared spectroscopy, this is the IR spectrum for 3,4,5 trihydroxy 1 cyclohexene carboxylic acid. The graph show a spectrum in transmission mode. It depends on the relative intensity in the IR spectrum. At the first peak, which is OH stretching absorb a lot of fragrance and have signals. That's why this peak have narrow peaks or bands. A broad peak by OH bands found in alcohols only and carboxylic acid as shown in figure 1. Based on the infrared spectroscopy, the peak of functional groups such as OH stretching at the first peak, CH stretching, C double bond C stretching of alkene, CH bending of alcohol, and OH bending of carboxylic acid at the last in figure 1. That's the functional groups found in the 3,4,5 trihydroxy 1 cyclohexene carboxylic acid, which is in the figure 1. Based on the structure, shows that the broad OH stretching frequency due to intermolecular H bonding, but in gas it shown the sharp peak for OH stretching due to absence of intermolecular hydrogen bonding. The sharp peak, which infrared peak of 3,500 cm of wave number for OH stretching at the first peak in the figure 1. So that's all from me. Thank you.
Next, for the NMR spectroscopy, structural features of the molecule will have an effect on the exact magnitude of the magnetic field experienced by a particular nucleus. This means that H atoms which have different chemical environments will have different chemical shift. For this structure, it has seven H atoms with different environment. So this is the first one, second, third, fourth, fifth, sixth, and seventh. So how to perform this structure for NMR? Firstly, you need to draw your structure and identify how many H with different environment will have. So since it has 7, the more shielding is the carbon with the double bond O, which is the carboxylic acid, since it has strong hydrogen bond and the pi bond. Next, the carbon atom with the double bond and neighbor with the OH, since it has strong hydrogen bond. They will be at the downfield, which is the most shielding at the left. Next, following with the carbon with the double bond, then with the carbon neighbor with OH, and lastly with the carbon far from the OH. And the last one will be the more shielding and upfield.
Assalamualaikum and good day, doctor. My name is Muhammad Faizal Ismail. My ID number is SA20063. I'm going to present about mass spectrometry for 3,4,5 trihydrocyclohexene carboxylic acid. Shikimic acid typically produce ions, which correspond to the molecular weight of the compound plus one proton. The ion of shikimic acid has a mass over charge value of around 173. Fragmentation of the ion can occur, leading to the characteristic fragment ions that provide information about the structure of the compound. For example, shikimic acid undergo fragmentation through the loss of water to generate an mass over charge ratio of 155 ion, corresponding to the fragment. Other common fragment ions include mass over charge 138 ions resulting from the loss of carbon dioxide and mass of charge 108 ions from the loss of two carbon dioxide molecules. When analyzing the ischemic acid by mass spectrometry, several ionization techniques can be employed, including electrospray ionization (ESI) and matrix axis laser desorption (MALDI). ESI is commonly used for polar and moderately polar compounds, while MALDI is suitable for both polar and nonpolar compounds. In MALDI, ischemic acid is typically mixed with a suitable matrix compound, such as alpha-cyano-4-hydroxycinnamic acid to enhance ionization. The matrix absorbs laser energy and transfers it to the unlike molecule, promoting desorption and ionization. Those resulting ions are then detected and analyzed in the mass spectrometer. That's all from me. Thank you.